Okay, causal loop diagram provides us some concept and how one factor influenced another factor. However, it was in our third experiment. Okay, we had to draw a certain level of diagram, or like we have to reason about its fluctuations. If we have further complex scenario, then it's very difficult to do. So here, system dynamics is being introduced to make this fluctuation and relations between variables become the computer simulation model rather than third experiment framework. So from causal loop diagram to system dynamics, causal loop diagram is excellent in terms of the conceptually modeling a causal, modeling a certain scenario. Here it says a tragedy of the commons, or let's say this is a scenario with a causal loop diagram approach. However, what's the weakness of the model? As the number of links being increased, it becomes more complex than human third experiment. Okay, so if we keep adding links and factors, more balanced and reinforcing loops, and we have to reason about them, is beyond our hand reasoning size or level. And many things are implied and hidden. Okay, so there was this positive causal link plus notations, but how much? We had this like delay annotation. How long will it delayed? Then those are the questions that we have to ask or specify to make them turn into a simulation model, or like exact executable models. Okay, so and since these are being fuzzy, the dynamics of the model is beyond our capture. So that we are going to add more flesh to this skeleton level, this skeleton cell causal loop diagram model, by turning it into a system dynamics model. Then we have to understand how to build and what's the notation of the system dynamics model, and how to add more variables, relevant variables, and details into the system. And finally, making an executable model. To understand the system dynamics model, let's explore its notation first. So notations for the system dynamics model. What's the most relevant features of the system dynamics model? Of course, the first thing to know is the stock. Here, stock is actually a variable. Remember causal loop diagram, one factor affecting another. These factors are actually essentially modeled here in system dynamics model as a stock. Okay? And this stock is a major modeling variable, can be specified for the initial value, and it has an automatic features of dx per dt. Okay, dx dt. What does it specify? As a time difference, how much x will change in the future dynamics. Okay, this is the rate. This is the speed. Okay, so how this stock will change is being specified, this dx per dt formula, and that can be specified for this stock variable. And another, the major modeling feature is this flow. Okay. So this flow is a model of relationships, adapters and the potential adapters. Okay, how it will change is being modeled, how these adapters will turn into potential adapters, or these potential adapters is being moved to the adapters, is being modeled by what? Is being modeled by the flow. Previously, positive or negative causal link can be specified by this flow. this flow can specify amount via formula. Okay, how much will be changing, so that it says rate. Okay, how much rate, and this rate will determine, and this rate and like this originating stock, these will be resulting the amount of flow. Potential adapters and adoption rate, this originating stock and flow specification will determine how much will flow from the potential adapters to adapters, right? And this flow will be only linked between the stocks, so that these stock fluctuations can be modeled only by the flow. And Professor, you mentioned that stock is it should be specified, automatically specified by being dt dx per dt. However, flow is maintaining the speed, rate, right? You said rate here. However, you see that there are multiple flows here. Flow can be multiply linked to the stocks, so that stock should be the dx per dt, and this flow will determine the partial rate, and this all aggregation will be represented to this automatically specified dx per dt. Okay? And we are going to add one more thing, which is being parameter. It's a modeling constant and specified at the initial stage. Okay, specified at the initial stage. Total population specified at the initial stage, and it doesn't change throughout the simulation. Okay, so that it is being simulation parameter being initially set, and that can be used to specify what stock or flow and so forth. And here we have a link, and that is specifying that usage. Right. Now we explore more notations for the system dynamics. First thing that we are going to cover is the link. The link is being specified between the variables. We are going to call this auxiliary or parameters and so forth. And these links are the relationship being used in a certain formula specified within the stocks, flows, or auxiliaries. Here we are going to call it auxiliaries. And here we have a dotted line. And this dotted line represents the usage at the initial stage. Okay? So this is meaning this means that it is being used at the initial stage. Then we are going to represent it dotted line. Otherwise, being utilized through the simulation time step, then we are going to have a solid line relations. And here we have auxiliaries. It's a secondary modeling variable. Secondary means that it is being derived from stocks or parameters. And even we can model the system dynamics model without these auxiliaries, okay? By linking directly from parameters and stocks and flows. However, that will make our model too complex. So that we introduce auxiliary to make them as a variable that can hold some variable information and can reuse for many usages. For example, here adoption from word of mouth is being affected by these parameters and this stock. Okay, all these 1, 2, 3, 4 links are coming in for this auxiliary. And that is being utilized where? Here, this adoption rate. Okay, that is being adoption rate. And this is meaning that these can all be linked to the adoption rate. to be utilized here at the rate formula. However, that will make our model too complex, so that we are making an auxiliary variable to do some level of computation, calculation, and make that variable, auxiliary variable, useful in the flow specifications. So, variable specified by a formula with the stocks and parameters or other auxiliary variables. That is being the definition of these system dynamics notations.